Welcome to this predicted paper from OnMaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. So for this question, I think of the ratio in terms of piles. So food is getting 37 piles of money and drink is getting 4 piles of money. So we've got to first of all work out how many piles of money we have. So we're going to do 37 plus 4 and that will give us 41. So we've got 41 piles of money. Now each pile is equal, so to work out how much one pile or one part is worth, and in maths we call them parts, but they're just like piles of money. We're going to do 13,161, the total amount of money, and we're going to divide it by how many piles there are, which is 41. When we do that, we get 321. So each pile is worth 321 pounds. Now, if we look at how many piles drink had, well, they had 4 piles. So we're going to just work out 4 lots of the 321. Which is going to be 1,284. So they spent £1,284 on drink. There's a formula we use for this, and it is percentage change is equal to the amount that's changed over the original amount, and all of that times 100%. So how much has changed here? Well, we need to do 10,488 take away 10,254. So that would be 234. Divide it by the original. So the original was 10,488 because it's decreased from that amount. And then times by 100%. And so that's going to be 2.23%. There is quite an easy way of doing this question, but I'm going to show you the long way and then we're going to work out what the quicker way is. So I'm going to pair up the A and the 1, which it suggests in the question. Then I'm going to work out the A and the 2 as a different combination, A3, A4, etc. Then I'm going to look at the B and do the same thing, B1, B2, B3, etc. Then I'm going to work out the C, so all the combinations with C. So how many combinations are there with A? Well, there's going to be 7 because there's 7 numbers. How many with B? Well, there's also going to be 7. And how many with C? Well, there's also going to be 7. So in total, there's going to be 7 plus 7 plus 7, which is 21. And the way I can work that out easily is work out how many combinations there are with spinner 1. Well, there's 3. How many combinations there are with spinner 2? 7. And we just times the 2 together. 3 times 7 is 21. The first thing we need to do is work out the area of the floor. And you'll notice that this is a trapezium. So with a trapezium, the formula is half A plus B times H, and A and B are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula, so it'd be half A plus B H, so half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, the next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total 11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. We can't work out what x is straight away, but we can find this value here. And we know with Pythagoras we can find a third length if we've got other two in a right angled triangle. So a squared plus b squared equals c squared. And a and b were labelled. C is always opposite the right angle, so it'd be 49 squared plus b squared equals 68 squared. And 49 squared is 2,401. And 68 squared is 4,624. So we are solving here, so let's get our lines down. And we're going to start by subtracting the 2,401 from both sides. So we've got b squared equals 2,223. Then we're going to square root both sides, and we've got b equal to 47.148, blah blah blah. Okay, we're now looking at the second diagram, and this time we're going to have a, we've got our b, and we're going to call x the c. So it'd be a squared plus b squared equals c squared, but this time a is 39. B we are given as 47.148, we've just worked that out. And we're looking for c, in fact we can call it x now. Okay, so we need to square that. So we do 39 squared plus 47.148 squared, and that will be 3,744 equal to x squared, and we'll just get our lines in because we need to square root both sides, and we get 61.188 blah 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 is equal to x. It says it wants its 2 decimal places, so that would be 61.19. A frequency polygon is like a line graph. In fact, it's a type of line graph, but it is when you have the data in a group. So we've got the data here as a group of 0 to 80. So there are 11 at 0 to 80, and then 18 at 80 to 160, and 6 at 160 to 240. Now, where am I going to plot this? It will involve putting a cross somewhere on this graph. And it would seem unfair if I put it all at 0, and it would also seem unfair if I put it all at 80. So what we do is we find the midpoint, the halfway point between 0 and 80, which is obviously 40, and we plot our coordinate there. So it seems to be going up in 2s, so it would be there. So that's at 40, 11, the coordinate. Our next one, we plot at the midpoint again, which would be 120, and it's just halfway between 80 and 160, and it's 18 high, so it would be up here. And then the final one is at 200, and it will be 6 high, so 200 is halfway, and we're looking at 6 high, so it will be here. Then when you're done, you need to join them up with straight lines. So I'm just going to get my ruler, join them up, perfectly straight lines, and there we are. First thing I'm going to do is just draw the square out, and we know the length of it is 10x plus 10, but it is a square, so that's the same all the way around it. But we're also told that the perimeter is 440, so the perimeter is 440. So what we can do is we can work out the perimeter in algebra by multiplying 10x plus 10 by 4, or just adding up the 4 lengths that we've got. So we're going to do 4 times 10x plus 10. But we also know that that is going to be 440 because we're told in the question that the perimeter is 440. So put our lines in because we're going to solve, and we're just going to start by expanding the brackets. So that'll be 40x plus 40 equals 440. Then we're going to get rid of the plus 40 first, so take away 40 both sides. And so that would be 40x equals 400. And then we get rid of the 40 before the x, so we divide both sides by 40. And we've got x equals 10. So our answer is 10. So I'm going to start just by writing out the equation. And I can put my lines in. Okay, we're asked to make x the subject. So we're going to first of all add 10 to both sides. In fact, I'm just going to move all this over a little bit so I've got a bit more space. Okay, so we're left with m plus 10 on the left hand side, and we've got 1/7 x on the right hand side. Now to get rid of the 1/7, what I can do is just times both sides by 7. So 7 brackets m plus 10 equals x. So x therefore would equal 7 brackets m plus 10, but it says expand your answer fully. So we're just going to expand the brackets, 7m plus 70. To find average speed, we do the total distance and we divide it by the total time. Now, in this question, we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08, and we're going to divide that by the hours, which is 0.2. When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a 1 decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done. We're going to first of all have to convert these both into the same unit. So we've got minutes and hours. That's not going to help us much. So what I'm going to do is pick the smaller unit, which will be minutes. So I'm going to keep that 50 minutes. And I'm going to convert 3 hours into minutes. That would be 180 because we times by 60. and I'm going to just remove the minutes now. And I can first of all divide by 10, and we want to try and make it nice and simple for ourselves. So divide by 10 would be 5 to 18. And we look at it, 5 and 18, actually there's nothing further we can do with that. So the ratio would be 5 to 18. So to find the gradient, we need the formula or the equation in the form y equals mx plus c. And the m there will give us what the gradient is. So we're just going to be rearranging this equation. And so I'll get my lines in. So the first thing I'm going to do is get rid of the x's from the left hand side, and we can do that by adding 6x both sides. So we've got 6y equals, and I'm going to put the 6x first, just to match the y equals mx plus c. Right, the next thing I'm going to do is get rid of this 6, because we just want a y there. So we're going to divide by 6 both sides. So we've got y equals 1x plus 36. Now we shouldn't really write 1, but because we're looking for m, we're looking for the number before x, I've kind of left it in there to show that the gradient will be 1. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So we're just going to substitute the values that were given into the formula. So v squared equals, and then u is 16.4 squared plus 2 times a, which is 0.2, times s, which is 110.2. Type that into the calculator and you get 313.039 blah blah blah. And what we're going to do is we're just going to quickly solve this by square rooting both sides, because it's v squared equals and we just want v equals. So v equals, and we're just going to square root that on the calculator, 17.692 blah blah blah. It says it wants it to 2 decimal places, so that's just going to be 17.69. There are 2 rules for things to be in direct proportion. The first rule is you must have a straight line, which we do on this question. The second rule is it must go through the origin. So we're looking for a line like this or like that, somewhere in that region there. Now this red line does not go through the origin, so A and B cannot be in direct proportion. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So, and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So we're given 21 to 4 is the ratio. We're just going to have our lines in, because what we need to do is make the left-hand side be 1. Okay. And to do that, for 21, I need to divide it by itself, divide it by 21, and we're going to do the same to the right-hand side. So 21 divided by 21 is 1. Perfect, that's what we wanted. 4 divided by 21 is 0.190, blah, blah, blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. So we can't work out length CE directly, but what I'm going to do is I'm going to start off by finding length BC. And I'm going to do that using trigonometry. So we've got the 90 degrees there. So it will be, well, we'll start by labeling it. So BC is the hypotenuse, the opposite here and adjacent here. We're not using the adjacent. So we're going to just do our SOHCAHTOA, and we've crossed out the A, so we cross out these two. So it's going to be sine. So we know that sine 79 equals the opposite, which is 29 over the BC. So I'm going to put my solving lines in, and we need to times both sides by BC first of all. So we end up with BC sine 79 equals 29, and we're just going to divide both sides by sine 79. Just a bit of rearranging. So BC will be 29 over sine 79. And when you do that in the calculator, you get 29.542, blah, blah, blah. Okay, so next thing we need to figure out is angle BCE. So where are we? This angle here. And to work that out, we're just going to take 79 away from 90. So angle BCE is 90, take away 79. And that's going to be 11. So we know this is 11 degrees here. And we have enough information now to work out CE, because we've got this triangle here, and we've got this length here, the BC, and we've got this angle here. So we've got enough information now. So we're going to look for length CE. We're going to first of all label the sides. So we've got the opposite here, the hypotenuse opposite the right angle here, and the adjacent here. So this hypotenuse is now an adjacent. We're not using the opposite at all, but we are looking for the hypotenuse. So let's do our little triangles now, find out which one we're using. So we're not using O, so we get rid of sine and tan, and it's going to be a cos. So it's going to be cos 11 equals the adjacent, which is the BC value we've just worked out, over the hypotenuse, which is CE. Now hopefully you've realised from when we did it with the sine thing here, that actually we can just swap these two things over. So we can have it as CE equals 29.542 blah 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 over cos 11. Okay, then we put that into our calculator and we get the answer of 30.095 blah blah blah, and it wants it to 1 decimal place, so that will be 30.1. So what's happened here is that the company's increased the amount of sweets by 15%. So we're just going to focus on that and work out what the multiplier would be first. So they started off with 100% and they added 15%, and then therefore they ended up with 115%. And to find that as a multiplier, we get the 115 and divide it by 100, and that gives us 1.15. So that is the multiplier they used. Now they used that multiplier on the original amount, and they times it by 1.15, and they got the answer of 69. But if we're working the other way to find out what they times by 1.15, we get that 69 and we divide it by the multiplier. So if we want to work out what the original number was, we divide it by the multiplier, and that gives us 60. So the answer will be 60. So we're asked to find 3a minus 2b. So let's work out 3a first. 3a is going to be the top times 3 and the bottom times 3. So the top times 3 is 9, bottom times 3 is 6. Then we're going to work out what 2b is. Again, times the top by 2, times the bottom by 2. And so 3a take away 2b is going to be 3a, which is 9 at the top, take away, and then the 2b, which is minus 2. And then the bottom will be 6, take away, minus 4. And so that's going to be 9 plus 2, which is 11. 6 plus 4, which is 10. So the vector is going to be 11 at the top, 10 at the bottom. With these questions, it's normally easier to view these as two separate triangles. So we've got a small triangle here with 19 and 47. And what I'm going to do is I'm just going to move this out. And we've got a bigger triangle here. And we've got, well, we've got a bit of, we don't really know what any of the sides are just yet, but we can work them out. Okay, now we know that both of these triangles are similar, and the reason is they share an angle and the lengths at the bottom are parallel, so they will be similar, which means one's an enlargement of the other. And we are given some information in the question that the ratio of BC to DE is 1 to 6. So BC is this length here, and DE is this length here. So we're actually given the scale factor because we know that 1 times 6 is 6. So we know the scale factor is 6, and it's asking us to find length AD. And so the corresponding length to AD, which is this one here. So all we need to do is get that 47, times it by the scale factor, so times it by 6 to get to our value. So it's 282. I'm going to do just a quick multiplication grid. And what I'm going to do is I'm going to put the 2x plus 3 at the top, so 2x and then plus 3, and then 3x minus 11 down the side. Multiply them out, 3 times 2 is 6, so that'd be 6x squared, 3 times 3 is 9, so that'd be 9x. Minus 11 times positive 2 will be minus 22x, and then minus 11 times positive 3 will be minus 33. Get them all together, so we've got 6x squared plus 9x, because that is a positive, minus 22x minus 33, and we can see here that the plus 9x and the minus 22x are like terms, so we can add them together to make minus 13x, and that's our answer. So our answer is 6x squared minus 13x minus 33. So we're going to start by finding the multiplier. So we start off with 100%. It says it's decreasing at a rate of 8.1%. So we're going to take away the 8.1%. And then when we do that, we get 91.9%. make that a multiplier by dividing it by 100, essentially making it a decimal. So whenever we get a number and we times it by 0.919, we're decreasing it by 8.1%. Now, there aren't any amounts given to us in this question, so we're just going to make one up. We're going to say that the population is 100, okay? And what we're going to do is type in 100 into our calculator, and then we're going to press the equals button. Now what that does is it stores the 100 in the calculator's memory. And it's basically, it's this next line that's the crucial bit. We're going to type in answer, which at the moment is that 100, times 0.919. And what that does is it says what the current answer is, we're going to decrease it by 8.1%. We're going to times it by that multiplier. And so every time we press the equals button, what it's going to do is it's just going to keep decreasing it by 8.1%. And we're going to count the amount of times we've got to press the equals button, because every time we press the equals button, it counts as a year. So when we first press it, it's going to be 91.9. Then press it again, it's going to be 84.4. So we're waiting for it to be beneath 43%. So if we started off with 100, we're looking for it to be below 43. So keep pressing it, keep pressing it. On the 9th year, we get 46.7, so that's close to that 43. Press it again, and we get 42.9. So it's 10 years. It's 10 times you've got to press it to get it beneath the 43. So sometimes it's easier just to do a quick diagram to see what's going on. So I'm going to say that the house is here and the shop is here. And so this person is walking to the shop, and then they walk back from the shop, but they don't walk as much. And we're looking to see the maximum distance the person is from their house. So we're looking to maximize this distance here. So we want this distance to be the biggest it can be. So we can see that we want to maximize this distance here, so that the shop is a long way away, and we want to minimize this distance here because we don't want them to have made that much distance towards their house, because we want to maximize that distance. So we're going to find the maximum for the 3,750. So it's to the nearest 10. And a trick you can do to find out what the upper bound is going to be is just half the accuracy. So 10 meters to the nearest 10, half of that would be 5, and then just add that on. So that's going to be 3, 6, 5, 5. That's the upper limit. We want to minimize this distance, which is 120. So the accuracy is still 10 because it says both measurements are to the nearest 10 meters. So we're going to halve that accuracy. 10 would be 5. And this time we're going to take it away. So 120 take away 5 would be 115. Okay, so to find the maximum distance the person is from their house, we're just going to do 3,655 take away 115, which will equal 3,540. We're going to write this out again just to give us a bit more space. So we've got S equals 4 minus 13t over t minus 5. I'm going to get our lines in. Okay, so the first thing I need to do is get rid of this fraction. Always get rid of any fractions. I'm going to do that by multiplying both sides by t minus 5. So we're going to end up with S brackets t minus 5 equals 4 minus 13t. I'm going to break open those brackets just by multiplying them out. So it's st minus 5s equals 4 minus 13t. And the objective here is to get all the t's on the same side. So I'm going to add the 5s and I'm going to add the 13t. So add 5s and then add 13t. And so effectively we're just moving this on the other side and this on the other side. So we're left with st plus 13t equals 4 plus 5s. Now when we've got the t's on the same side, we can factorise out the t's. So t bracket s plus 13 equals 4 plus 5s. And then we can get rid of this by dividing both sides by s plus 13. And so we're left with t equals 4 plus 5s over s plus 13. So our answer is 4 plus 5s, all of that over s plus 13. And it can be either way around, so I could have 5s plus 4 over 13 plus s, or anything like that. The first thing to notice is that 125 is 5 cubed, so instead of 1 over 125, it would be 1 over 5 cubed. And we know that when you have a negative power, it actually turns into the reciprocal of that number. So 5 to the power of minus 3 becomes 1 over 5 to the power of 3. So n is going to be this minus 3. Whenever you're asked to work out a proportion of items in a histogram, you can actually do it by just counting the squares. So in the first bar, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 squares here. The next one, you've got kind of 4 half squares, so that will be 2 squares in total. And then we've got 4 squares in the last one. So altogether we have, for the amount of squares, we have 12 plus 2 plus 4, which will be 18. So it's 18 squares in total. Now it says that we're looking for between 25, which will be here, and 45, which will be here. So we count the squares in this little interval. So there are 3 here, and there's half a 1 here. So the squares between 25 and 45, I should say dash 45, 25 to 45 is 3.5. Okay, so we've got 3.5 in total, or 3.5, out of a possible 18. So we just need to do 3.5 divided by 18 to work out the proportion, and that gives us 0.194 blah blah blah. It says it wants its 2 decimal places, that would be 0.19. We're going to start by working out what outcomes will give us 2 different types of drink. So we could have OA or AO. We could have AW or WA, and we could have OW or WO. Now what we notice really when we do this is that OA gives us the same probability as AO, same with AW and WA, same with OW and WO. So we're going to just ignore the right hand side ones, and we're just going to focus on the left hand side ones. To work out the probability of O and then A, so orange juice then apple juice, we work out the fact that it's 6 over, or the probability of picking orange juice first of all is 6 over 27. And then if we picked an orange juice, the probability of picking an apple juice would be 9 over 26. And so that would be 54 over 702. Apple juice then water would be 9 over 27, and then 12 over 26, and so that would be 108 over 702. And then orange juice then water will be 6 over 27 and 12 over 26, and that would be 72 over 702. Now we're looking at the probability of this or this or this, and the word or means add. So the probability of OA or, I should put that in brackets, probability of OA or AW or OW is these added together. And when you add them together, you get 234 over 702. Now, I said we would deal with the reverse situations now. I'm going to deal with that now. And as I said, OA is going to be equal to AO, AW is equal to WA, and OW is equal to WO. So all we need to do to find the probability that the drinks are different is get the 234 over 702 and just double it. And we can do that by just doubling the numerator. So 468 over 702. That cancels down to 2/3. So there is a 2/3 chance that the drinks will be different. So with all these circle theorem questions, there's multiple ways of doing it. I'm going to show one way, but if you've got a different way and you get the right answer in correct methods, then please feel free to use that. First thing I'm going to notice is we've got a lot of tangents touching radii. So we've got two radii here and here. And whenever we've got a tangent touching a radius, it's always going to be 90 degrees. And so I'm just going to show these all on the diagrams 90 degrees. And then we're going to say angle OBC equals angle OBA equals angle ADO equals 90 degrees. And we have to show the reasons. Most of the marks in this question will be for the reason. So it's going to be a tangent radius equals 90 degrees. And try and write out the full reasons. I'm going to just keep it a little bit contained, just so I can fit this answer all on the same slide. Okay, so the first thing I'm realizing is that there's a nice little quadrilateral here. And whenever we've got quadrilateral and we've got three of the sides, we can work out the last one. So angle DOB is going to be 360, take away the angles that we know, so 90 plus 90 plus 48. And the reason for that is angles in quadrilateral add up to 360 degrees. And so when you do 360, take away that, you get 132 degrees. So this is 132. But we also have this angle here, which is also angle DOB, but I'm going to call this kind of the reflex one. And to work this one out, we just do 360, take away 132. And the reason for that is angles on a point equal 360 degrees. And so we're going to do 360, take away 132, which is 228. So this is 228 degrees. Now we can also use the circle theorem to work out this one, because we've got an angle at the centre and an angle at the circumference. And the angle at the centre is twice the angle at the circumference. So angle DFB is going to be 132 divided by 2. Angle at centre twice angle at circumference. Okay, so when we halve that, so 132, and we're going to halve it, so that's 66 degrees. We should really put degrees on these. Okay, the next one we're going to work out is this angle here, which is angle OBF. There's no reason for this, it's just the whole thing is 90. We're taking away the 77, so that would be 13 degrees. So that's a nice easy one. And let's just put the 66 degrees on our diagram as well. And the final thing really here is that we've got a quadrilateral here, kind of arrowhead, and we've got three of the angles, 1, 2, 3, and we're looking for the third one. So angle ODF is going to be 360, take away all the angles that we know, so the 228, the 13 and the 66. And the reason being the same as before, so angles in quadrilateral add up to 360 degrees. And when you do that, you get the answer of 53 degrees. So this angle here is going to be 53 degrees. When asked to simplify an algebraic fraction, you will almost always need to factorise either the numerator, the denominator, or both. On this question, we need to factorise both. So I'm going to start off by factorising the top. Now you'll notice that this is a difference of 2 squared, so this is nice and easy to factorise because it will be x plus 2 and x minus 2. And we've got loads of videos on how to identify and deal with difference of 2 squareds if you don't know how to do that. Similarly, the bottom is just a simple quadratic, so we're just going to factorise that. Again, we've got videos on how to factorise quadratics, so have a look at those if you need to. Then we're going to look at top and bottom and see if there's a bracket that's the same, which there is, this x minus 2. So we're going to divide top and bottom by x minus 2, and that will effectively get rid of the x minus 2 at the top and the x minus 2 at the bottom. It won't get rid of it, it will just turn it to 1, and then it will be x plus 2 times 1 and 2x minus 3 times 1, which will just be x plus 2 as the numerator and 2x minus 3 as the denominator. So simultaneous equations we normally solve by working downwards and doing the circles and using the normal method on them, which is solving simultaneous equations by elimination. Sometimes though, when we've got a linear and a quadratic, which we have here, it's not possible to do that method. So what we've got to do is substitute one equation into the other. Now here, it's actually been nice to us in this question because they're both equal to y. So I can replace that second y with the 2x plus 11. I can just put that into that equation there, which is what we're going to do. So we've got 2x plus 11 equals x squared minus 5x plus 4. And we're just going to get everything equal to 0 so that we can solve it as a quadratic. So I'm just going to start by subtracting 11 both sides. So we've got 2x equals x squared minus 5x. What's that going to be? That's going to be minus 7. And then take away the 2x both sides. So we're going to have 0 equals x squared minus 7x minus 7. Now, we know this is not going to factorise nicely because it asks it for 2 decimal places. It's on the calculator paper. Chances are it's going to be quadratic formula we'll need, which we do. So we've got a equal to the coefficient of the x squared, which is just 1. B equal to the coefficient of the x, which is just minus 7. And then c equal to the number unknown at the end, which is minus 7 also. So we write out the quadratic formula. So x equals minus b, and always put them into brackets, so minus 7 plus minus the square root of b squared, so in brackets minus 7 squared, minus 4 times a, which is 1, times c, which is minus 7. Oh, and all of that over 2a, so 2 times 1. And when you do that with a plus in that bit there on the calculator, we get the answer of 7.887 blah blah blah. When you do it with a minus, you get the answer of minus 0.887. And don't rewrite the whole formula when you change from plus to minus. Just use the calculator function to go back to this sign and just delete it and change it to a minus. But when we solve, we've got to find out the x and the y values. So we look at this first equation here, which says y equals 2x plus 11. It means to find out what y is, all we need to do is times it by 2 and then add 11. So I'm just going to do that with the first solution we have, so 7.887, blah, blah, blah. I'm going to times it by 2 on my calculator, and then plus 11. And that gives me the answer of 26.774, blah, blah, blah. Then I'm going to do that with the second solution we found, so minus 0.887, blah, blah, blah. Go times it by 2, then add 11, and that gives me 9.225, blah, blah, blah. So to 2 decimal places, our answers are going to be 7.89 and 26.77, or minus 0.89 and 7.23. To answer this question, we're going to do something a bit weird on the calculator, and this is a method you might not know, but it's the quickest method for answering this question. And what iteration basically is it's feeding the previous solution into the iterative formula to get the next solution, and you keep going and it will get closer and closer to an answer, and then we write down that answer. But on our calculator, what we're going to do is just press the button 1 and then equals. Now what that will do is it will store the 1 that we have here in our calculator. Then we're going to type in the cube root button, and the 1 will disappear. That's not a problem, because the next thing we're going to press is answer plus 10. So on your calculator it should look like this: the cube root, and then answer plus 10. When we press the equals button, what will happen is it will work out what the next number is in our iteration. So if we press equals, we get 2.22398, blah, blah, blah. Because we're looking for it for 3 decimal places, we're just going to work that out to 3 decimal places. So it'll be 2.224. Then all we need to do now is press equals again, because instead of using the 1, it will use the 2.223980091, etc. as the answer. So I'm going to press equals again, and lo and behold, I get 2.304. Press equals again, 2.309, equals again, 2.309. Now, when you get the same answer twice, you can stop. That is our answer. So our solution is 2.309 to 3 decimal places. To start off this question, you need to realise that EGH is a right angle triangle. And if I draw it in on the diagram, and then let's draw it as a 2-dimensional right angle triangle, and hopefully we can see how to answer it. So if we put in the values, 4 centimeters there, 5 centimeters there, and we can find length EG by using Pythagoras. So let's try and put in some Pythagoras. So we've got EG squared equals EH squared plus GH squared. And I'm just going to put tram lines down. Okay, so EH is 4, so it'd be 4 squared. And GH is 5, so it'd be 5 squared. And that's going to equal 41. And we're going to square root both sides. So we've got EG equals 6.403, blah, blah, blah. Okay, so that gives us what EG is. So we know that this is 6.403, blah, blah, blah. Now, we're looking for angle GEC. So we need to draw in another triangle onto our diagram. We'll do this a different colour. So GEC, the triangle would be here. Okay, and so I'm just going to draw that triangle as a 2-dimensional triangle. And again, it's a right angle triangle. The height is 6. The width, or the base of the triangle, is that 6.403 blah 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 that we've got. And the angle GEC is actually this angle here. So this is angle GEC. Okay, and we can show it like that. Now, to work out what GCSE is, it's not going to be Pythagoras anymore, it's going to be trigonometry, because we're looking for an angle. So we know that we first of all label the sides. So we've got the opposite, we've got the adjacent, and we've got the hypotenuse. We're not using the hypotenuse at all, but we are given the opposite and the adjacent. So it is going to be TOA, and those of you should know this off by heart, that the TOA shows us that the opposite will be over the adjacent. So we have tan GEC equals, and that's the angle, equals the opposite over the adjacent. And let's put our tramlines in. Okay, so let's just put in what the opposite is. The opposite is 6, and the adjacent is that 6.403, etc. And I'm keeping it in my calculator so I can make sure that I don't lose any accuracy. You can actually round it to 6.403. Just try and round it to a sensible degree of accuracy, say 3 or 4 decimal places, and that's fine. If you round it to, say, 6, then it's going to have a big influence on the answer. I'm going to inverse tan both sides to get rid of that tan, and so that would just leave angle GEC. I normally just put a little thing there to show it's an angle, and we're going to inverse tan the 6 over 6.403. Now in the calculator, what I'm going to do is type in second function tan to get the inverse tan, and then in the bracket do a fraction button, then 6 over, and then I type in answer because 403 was my last answer. It just keeps the accuracy up. It's absolutely fine, you get full marks if you write inverse tan of 6 over 6.403 and just leave it at that, that's fine. And so angle GEC is 43.138, etc. Now we don't need any more accuracy in that because it says that the answer should be to 2 decimal places. So all we need to do is round that to 2 decimal places, which will be 43.14. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.